Hi everyone, this video is about ionic strength, and let's recall how the solubility of silver chloride increased in the presence of spectator ions. And remember, that's because the spectators lead to these ionic atmospheres that prevent the precipitate from forming. We can actually quantify the presence of spectators using ionic strength, which has the symbol mu, and there's an equation for it. Mu is defined as 1/2, and then we're going to take the concentration of our first spectator multiplied by its charge squared, and then we're going to add the concentration of our second spectator multiplied by its charge squared. And you keep doing that depending on how many spectator ions you have in solution. So we could rewrite this equation as 1/2 times the sum of C sub I times Z sub I squared, where again the C is the concentration of the spectator and Z is the charge of the spectator. So let's try to do an example. Let's see if we can calculate the ionic strength of 0.1 formyl potassium nitrate. So mu is going to be 1/2, and it'll be the concentration of the potassium ion times its charge, which is just +1 squared, plus the concentration of nitrate times its charge, which is -1 squared. So we have 1/2 times the concentration of potassium here would just be 0.1. 1 squared is just 1, plus the concentration of nitrate in this solution, which would be just 0.1, minus 1 squared is just 1. So our ionic strength then would be 0.1 molar, which in this case happens to be the same as the concentration. And that is a handy thing to remember. So I'm going to write it down. It's an important note that the ionic strength equals the concentration, like it did here, for salts with a +1 cation, like potassium was, and a -1 anion, like nitrate was. This will be useful to remember. But let's do another example that's a little bit more interesting, where the ionic strength doesn't equal the concentration. Let's consider this salt, sodium sulfate. We have a +1 cation, but a -2 anion. So mu is going to be 1/2, and it'll be the concentration of sodium times its charge squared, which is +1, plus the concentration of sulfate times its charge squared, which is a -2. So we have 1/2, and then what would be the concentration of sodium in this salt? Well, for every 1 mole of salt, we have 2 moles of sodium, so it would be twice this, wouldn't it? The concentration of sodium would be 0.1 molar. Its charge squared is just 1. And then the concentration of sulfate here would just be 0.05 molar. And its charge squared would be 4. So we have 1/2 times the quantity, 0.1 molar. And then if we do this arithmetic here, we get 0.20 molar. So we have 1/2 times the quantity, 0.3 molar, which ends up giving an ionic strength of 0.15 molar, which is quite different from the concentration. So I hope you try doing some of these examples on calculating ionic strength on your own, and thanks for listening.